Wasim sir, can you say?
Hello.
Yes, sir, you are audible now.
Okay.
So please share your presentation and we will start. A
I
very
have
good
already,
morning to all of you.
shared.
Yes, sir.
Mm.
A very good morning to all of you. Today, our esteemed guest is Dr. Wasim Hassan Raja, sir, is senior scientist and food track at ICAR, Center Institute of Temperature Horticulture, Youngate, Srinagar. Sir, you are audible, visible. Your presentation is visible. Sir, please continue. We welcome you all.
So how many participants are here? Can
31 participants have joined it so far.
okay. Okay. Good morning to all. Uh, and let me know how much time I have.
So, 1 hour. You can take 10 minutes extra, minimum 1 hour.
Minimum 1 hour.
Yes, sir.
I will try to finish in 45 minutes because I have to prepare myself for new daily today. I have to do this. And very important. So within 45 minutes, I will try to finish it.
Wasim
Is
sir,
it
your
okay?
voice is not clear. Wasim sir, your voice is not clear. If you can come forward a bit.
It takes 8 minutes. 8 minutes. 8 minutes. 8 minutes. Now, is it now clear? Is it now clear?
Yeah, yeah. Now it is clear. Now it is clear.
ठीक करना ये कुछ करना पड़ेगा it's okay now. Can I start?
Yes, yes, you can start.
So you have already gone through various training programs regarding this lecture regarding temperate food because we are dealing with temperate food. Our region is temperate and our institute is also temperate. So we are mostly working on the temperate food. But if you have any question or query regarding the tropical or subtropical food, we will try to give you the answer because my study is mostly from outside. I have done my PhD from Indian Agriculture Research Institute, New Delhi, under the dynamic leadership of Dr. S.K. Singh, who is presently holding the post of the DDG Horticulture. So I have been the lucky to get the guidance from such an esteemed and knowledgeful scientists of country. So uh, now I will start my presentation. My presentation is mostly breeding aspect, but I will give you the overall scenario of the temperate horticulture. It is not only temperate horticulture, but it is also the you can say horticulture because most of the trees, uh, whether it is mango, whether it is guava, whether it is any other tree crop, the physiology is same, the challenge are same, the aspects are same, the breeding objectives are same, but with a little difference as in temperate foods, most of the plantations are on rootstock. So I will explain you. Most of you might, if you are from agriculture background or horticulture background, you must know the you might know the about the rootstock. But here also I will try to explain the rootstock. So this is the little bit of introduction. I will not go in detail, but I want to share you here that most of the temperate food, whether it is apple, whether it is pear, whether it is plum, stone fruit, whether it is cherry, they are introduced. That means their origin is not India. They have been introduced mostly from the Central Asia or from Europe or from USA. And the same trend is continuously going there. We are also now what we started in the historic time that we introduced. Now still we are introducing the latest variety, latest food stock, latest system from those countries. So, whatever improvement happened in the country so far, I am saying about temperate food, that is only through introduction of promising varieties from those countries. So there was no, there were some breeding programs in, you can say, on small scale, organized breeding programs, but the varieties produced through those breeding programs were of not so good quality as compared to the varieties introduced from outside. So the farmer will not go for a less superior variety to the more, he will always prefer the more superior variety. So because he have to sell his produce in the market, uh, so he will develop the orchard, he will select the variety, he will select the rootstock based on his you can say, based on the market demand and availability of those varieties. So I will tell you a little bit about this rootstock because you might have heard a lot about this in previous lecture. You can ask me questions in between also if you find any difficulty in understanding, and I will be happy to answer, and I will feel very happy if you will ask some questions in between also or at the end of the session. Actually, rootstock is the root. The plant comprises of two parts mostly. Uh, some are seedling also, but mostly I am saying about what is the current trend. It is the rootstock that constitutes the root system, and little bit of the trunk part, that means up to 6 to 7 inch, and secondly sign which is the variety, which is a genetically distant floating part of cream, the sign that upper part of the portion, which is the variety which we want to graft on the rootstock. Sometimes there is a interstem also. I will not go in detail about that. What is the role of interstem and what in which crop it is used. Some crops is used to uh, avoid and to overcome this graft incompatibility, but I will not go in detail. But I want to share one thing that in case of temperate fruit, uh, in some fruits, like most of the fruits which are grown in other parts of the country, like mango, the variety is very important. Whether it is Langara, whether it is Tosa, whether it is Amravali, whether it is this Alfonso, whatever variety is important. But in case of apple, or in case of pear, or in case of plum, the rootstock is as much important as variety because rootstock will govern the 80% of the size of the plant, the yield efficiency, which is very important because in the case of tropical and subtropical food, there is very less concept of yield efficiency. But in case of temperate, it is very important. Uh, so, okay. So both of the rootstocks in apple, I will discuss about the apple first. Have been developed from the European countries, and they have been selected keeping in view the lot of benefits because earlier plant people used it to plant the trees to seedling or raise it by from seed. And as you know that apple is a cross-pollinated crop and it is heterozygous in nature. Most of the melons species are heterozygous in nature. So there will be lot of variability because the seeds plants raised from seed are very vigorous. Their juvenile phase is very high. That means juvenile will be more. They came into bearing very late, and the size of the plant is very big, and there will not be uniformity, and every operation will be difficult because you can say you are not taking the And you cannot avoid various types of soils because sometimes there are problems in soil that can only be managed if we are using the rootstock. But also, there are a lot of problems in apple. Still, work is going on to overcome those problems, mostly by rootstock breeding. That I will discuss in the coming this, slides. But mostly the rootstock has a lot of benefits, and these are some of the rootstocks are active, which have been introduced from outside. We also have almost 20-30% of these rootstocks, which are mostly currently used for the development of the high density orcharding system or ultra high density orcharding system in apple. You can say how much is the variability available in apple rootstocks in case of the vigor of the tree only. There are many other benefits which we will discuss in coming slides, but we can see the only the that there is seedling if it is 25 feet, and if you see the left side of this photo, then picture, then you will see that B9, B Geneva 11 or M9 T57 is 30% less than the seedling. That means by almost there are a lot of other benefits also which I will discuss here, that these rootstocks should have those qualities so that every farmer can adopt these. But fortunately or unfortunately, we have a lot of rootstocks. But what I have written here, most of the rootstocks don't have such qualities. One of the other problems they have. So the breeding improvement program is still going on. Like tree standing, if you take tree standing, then you have the yield efficiency problem because tree standing is good in seedling and M90 or 106 or M7 also. But if you want the high yield efficiency, then you have to go for M9 PCP7 and B9 or Geneva 11. Then you have to install the trellis system. So there are merits on the one side, and there are demerits on the other side if we take all the aspects. But mostly, if you take the new system, the benefits or merits of new systems are comparably or much more than the demerits along with them. So these rootstocks not only give the yield efficiency, high yield efficiency, but they give good quality fruit. 80% or 90% of the fruit developed on the new latest system or rootstock is high quality. Those rootstocks are easy to multiply, and they are resistant to most of the diseases. Some are tolerant, some are resistant, and some are also resistant to woody aphid. Woody aphid is a very big problem in case of mailing series rootstock. That I will discuss later. That how breeding has been done. And also SAR. SAR is a new problem because we are mostly now uprooting the old plantation and planting new, doing new plantation. So there are problems of apple replant disease problems. So breeding have been started for this program also in the world, and we have some roots like Geneva 11, Geneva 41. They are very much resistant also against SAR. So I will not go in detail of the history of the apple rootstock development, but I will tell you how this comes into figure. It was 20th century, beginning of the 20th century, when uh, East Mailing Station in UK screened 16 types of apple rootstock, and they named them from M1 to M16. And they were mostly selected from the forests, and earlier they were have been used for the raising of apple rootstock, apple plantation, but they have not been designated. So there were a lot of confusion among the rootstock, but the East Mailing Station started to uh, arrange them and characterize them and denominate them. and have been denominated from M1 to M16. And then in 1917, the uh, uh, East Milling Station was the first station who started the breeding program in the world. And then after that breeding has been started, there were various breeding programs started by several countries. But one thing I want to clear that, and there were also the release of the various things from those breeding programs, but their objectives were area specific objectives. Like you can say in case of Europe, Eastern, the problem was woolly acid. Woolly acid is very devastating insect which is devastating the buildings in the nursery. And in the same way, you see the USA, there was the problem of fire blight, and there was the problem of root rot and cholera. So they started the develop root stock as per the requirement. And same was in the case uh, was in with his USSR, former USSR, you can say Russia. They have the more freezing damage of those root stocks. So they started the breeding program for freeze tolerant root stock, and they released the B series. In the same way, Poland also they have the freeze tolerant freezing problem, and they have some more problems than this released T series root stock. So then there were many more breeding programs worldwide, almost 26 breeding programs. But I will say you one thing that most of the plantations now presently on M9 rootstock, which has not been produced by breeders, and B9. B9 is the breed. B9 has been produced by the breeding. And now the new rootstock has come, rootstock series. And these are the different breeding programs which have been started in many countries. Then Russia also started. Then Israel also started. Romania also started. Germany also started. Germany has also produced J series rootstock pollination network support a series from the research institute which is located in Dresden. Last year we had the opportunity to visit that station in Dresden, Germany. They have stopped this breeding program at Rootstock because they told that the breeding we have started it, but the acceptance of our rootstock is very less, so we have discontinued those programs. But still, in most of the countries now, new breeding programs are coming up using the latest technology because it is a time-taking process. It is not very easy to develop a rootstock and then to use it farmers. You need multi-location trials, and it took almost 20 to 25 years to develop a rootstock and to release the rootstock. So almost there was a major apple rootstock programs throughout the world that the targets were here. So as I told you earlier that the targets were different. It varies from the country to country, and now there are new challenges coming. Newer challenges are coming, like we have now virus problems. Earlier, very less focus was the virus. Now we have nematode problems. We have other problems. Soil abiotic factors, then a lot of biotic new factors. And we are using the same area, we can say location, for raising the next plantation, because earlier the age of the orchid was 50 years, 60 years, 70 years. Now the age of the orchid has been reduced to 20 years or 15 years. So we have to plant and it was earlier the extensive type of system. We were doing this on the larger areas because earlier the number of plants per hectare were only 250. Now we can accommodate up to 8,000 plants per hectare. So it is a more intensive and it needs a lot of other things to be considered. So these are the sources of we can say which are used for the different different disease or pests like root rot. We are using Melasthema. We don't have here in India, but we have bucket. I will discuss about that. That is also possessing some properties. And for salt tolerant, they are using Melasthema. We have introduced this earlier. And for early flowering, they are using yellow bucketa. Bucketa, India have two species here, two species of Melas species, you can say. One is Melas bucketa, which is found in Himalayan region, mostly Himachal Pradesh, Jammu and Kashmir, Uttarakhand. And we have Melas sikkimensis, which is found on the China, in the China border and Sikkim area of India. So we have collected those all. We have tried to collect the variability last several years, and we have been able to. That I will show you next slide. So this is the how we can reduce this. We can say the disease cycle by molecular assisted selection. We can reduce the one way the population size, and secondly we can reduce the disease cycle also. But most of the this genes have not been studied in case of attribute stuff. Whatever the information is available, so that information is lying with all the scientists who are working in these aspects. We are also doing this. We are also reducing the population size by using marker selection for different traits like dwarfness, DW1 gene is here, and then for uh, woolly acid markers are there. Then root rot and color rot. We have all those markers, and we are also using those. By using the markers, we can reduce the breeding cycle from almost half, you can say. But even then, we have to, if you will see the longevity, long zonality. Zonality, there it is a, you can say, polygenic character. You have to study it in the field. So it will take its own time. And other many the traits like qualitative traits are concerned. You, if you are confirming it to the market, you have to do the field evaluation because finally those rootstocks have to go to the field. And finally, how they are expressing those genes and because genes are expressed not by the genotype but also by the phenotype and the microclimate which is available to express their genes. So this is the East mailing which have started. Two scientists were here, Dr. Wellington and Dr. Hatton, who have uh, who have collected those rootstocks and then they have done the, you can say, denomination of those rootstocks. So actually, there were no lot of rootstocks of same name, like Paradise. One rootstock was named Paradise Docent, but now Paradise is called M9. So they reduced the because in every country they had their own names. So they collected them, they evaluated them, and they removed the admixtures. They removed the this what was contained here. Then they named them. These are the named earlier rootstocks which have been first collected from out there. Like you see, M1 was named as broad. Common name was broad-leaved English paradise. So M9 was called John D. Murdoch and Paradise series. So, but they named it M9. So they also uh, engraved it is correctly that it is dwarf. Same way, broad-leaved Paradise M1 was vigorous. So they named it M1 and also it's correctly as vigorous. So M3 was given no name, like M6 was given name reverse non-sex paradise. So it was renamed as M6 and then it's correctly as very vigorous. So He was the Patton and Wellington were the first two scientists who renamed these rootstocks, and they properly classified them. So what we have available so far, that is with the name of M9. But there are a lot of trends of these rootstocks not available with us. Even with even in M9 there are lot of strands. So I will not go in detail, but because that is not of much concern for the common Chinese. But there are 9 or 10 strains of M9 available with us at CATA Srinagar. That is M9, M9T27, M9T29, M9 NACAP 1, NACAP 2, Lancer, lot of these stuff of M9 also, Pajam 1, Pajam 2. So there is variability now, but those are all have been screened or they have been selected from. They have not been developed the breeding or so now the currently most of the plantation are on M9 or M9 strains. So then they have developed MM series, Marling Merton series. Marling Merton series is just the cross of the M9 and Northern Spy. Northern Spy was a rootstock used there, which was highly resistant to woolly acid. As I told earlier, that woolly acid was the major problem, and still it is a major problem now in apple rootstock. But they tried to develop some rootstock from the cross, and they were successful in developing a lot of crosses, and then MM series developed. So MM series after M9, MM series is the second series which is being used for the development of the orchid. Two famous rootstocks in this which are currently used in not in the world but also in the Kashmir, Himachal and other parts like MM106 and MM111. They are currently being used. So they also tried to develop the virus-free planting material. But the problem was at that time where that when they selected the virus-free planting material, the size of the sign and rootstock increased up to 10 to 20%. So these were not very famous, but now we have the stand or the idiotat or the of different strands we have available. They are being used. These are the rootstocks, and among these, MM111 and MM106 are uh, used at the large scale. MM106 is also very good rootstock, but the problem is it is highly resistant to it is highly susceptible to root rot. So if we are planting the orchid on MA106 next year, we have 10% mortality with root rot. Next year we have another 10%. Then this cycle is continuing, and this is the problem. Otherwise, it's very good rootstock. It doesn't need the trellis, but it needs simply this. You can say we have planted the cost of the establishment of orchid is less, and it is highly resistant to woody aphid. But the problem of this woody aphid problem is of nursery problem now. It is occurred in nursery, and but uh, this root rot is uh, devastating the plantation, really devastating. You can say there's a lot of who is motivated with this type of plant. And MM111 is also very good rootstock. This is also resistant to woolly acid, but uh, it can be used at the site where there is uh, less availability of water. We cannot say drought. It is not actually problem to drought, but in comparison to M9, it needs less water, and in comparison to MM106, it needs less water, and it is somewhat tolerant to root rot. Less root rot is there, woolly acid is not there. But the problem is yield expensive. It is not so expensive as M9 or M106. So I will not go details. These are the new rootstocks. You can say these are the subcolumns of M9. You can say different countries have um, uh, selected these rootstocks, screened their population, and then selected these rootstocks initially. And these all rootstocks are now being used because we are also importing those rootstocks like we are if we are importing from Netherlands, then M9 fluorine 56 is there. It is basically M9, but it has been selected by as a subcolon. It is subcolon. It is not by breeding. It is not by any other, but it is just a subcolon of original M9. In the same way, MMP327 is mostly used current, which is currently used as a root at the world level. It is almost 60 to 70% plantations of the world are coming on this root stock M1957. Pajam is also very good. We last year it is from Belgium farm. It is less developing than M9 Inla, but the problem with this rootstock is that it is not as excellent as M1957 in case of yield excellence concern. These are some of the rootstock, new rootstock, and I have not seen any of them have been released so far. So these trials are going on, and maybe in the future we will get some rootstock out of this. These are different rootstocks of mailing and which have been released for Apple and also for Peer. Peer is very good. If you see the temperate fruit among home fruit, Apple Peer is very important because in the world level also, after Apple, Peer is the second most important. Peer is the second most important temperate fruit crop. But we have very less understanding of Peer. So, but there are a lot of benefits, and I will show in coming slide how we have started the year program here. So then the newer breeding programs are they have been started by the USA Geneva, and they have the objective of fire glide and phytophthora. They have a medical source of you can say a current medical you can say they have that is Robusto 5. Robusto 5 is the source of all these things. Robusto 5 is resistant to fire blight. It is resistant to phytophthora. It is resistant to woody acid. They have selected it somewhere in Central Asia, and they are using is one of the most important parent now in their breeding program that Robusto 5. All these breeding these rootstocks which are currently being grown in the world level, most of these rootstocks are resistant to all these, most resistant or tolerant to phytophthora, fire blight, and also to other plant disease problems. So this is the list of Geneva series. Among them, we have recently introduced Geneva 11, Geneva 41, Geneva 202, 896, and 210. These routes are very good, and but they have some problems. They are very difficult to you can switch up a bit. So they are working on that aspect also. So this is the general characteristics of what Geneva rules of Apple have there, what traits they are working for. The most important is fire glide. Almost 20% of the plantation in USA is there is a mortality of 5% every year, 5 to 10%. Root rot is also a major problem. And replant disease also is now a major problem. And cold hardiness, because you can see now extremes of temperature are increasing. Both sides, low temperature and high temperature. We experience it here 37 degrees this year. We have not usually experienced it in last 34 years. These are the rootstocks related from Geneva. And now we are promoting it on large scale to other countries, other parts of the country. Actually, what is different between the developed countries and uh, underdeveloped or developing countries is that they are developing the product and they are promoting it and trying to reach it to the end consumer. We are developing products, but we are not taking it to the end consumer. So our product, our product, even if it's good, we are not able to. I will tell you the story of Geneva because they have developed a lot of rootstock, but there are a lot of problems associated with these rootstock. Even them they are promoting. some lot of benefits are there, but problems are there. And but even in spite of those problems, they are giving it to the consumer. They are giving it to the architect. This is their strategy, and because they are converting the research into money or product. These are the new root stocks. Still grading is going on, and they are still working on. 2008, you can say they have revenue growth 41 like that, 41. It is not so old, but a sizable 20 or 30% of the USA orchids are on their website now. You can say how fast they move and how fast they promote these root stocks. So that people will get a benefit and their share will increase in the, and now they are sending it to other countries for the integration. So these are the rootstock I will not discussing. Please mute your mic. So these are the general traits of January stock. I will not go in detail. So this is the Russian breeding I earlier explained to you that they developed for this problem because Russia is one of the coldest countries in the world where a lot of snowfall is there. And then comes the next is that other plants. Other plants are currently being used. The new concept in Apple orchid development. Please mute your mic if somebody is in.
Somebody is having his mic open. Please mute it. Tejas, Dr. Tejas, please mute your mic. Sorry, yes.
The importance of feather plants. If you will come to here, temperate region, you will understand the importance of the feather plant. Because in market, you are getting the price of the tree based on the feathers. If you have no feathers, it will fetch you 200 rupees or 150. If you have 2 or 3 feathers, it will fetch you 300 rupees. If you have 5 feathers, it will fetch you 400 rupees or 500 rupees. If you have more than 10 feathers or 8 feathers, it will fetch you 700 rupees. If you have more than 10 or 13 feathers, it will fetch you 1000 rupees per plant. So the cost of the plant is decided by the number of the feathers it has at the time. It was a big challenge. Me and on the more side, Dr. Kumar, we were the PI of that project. We have been able to develop a technology which can develop a feathering in 1-year-old wheat plant. So there are a lot of benefits of these feather plants. You might have heard already because lectures were there of and scientists or they are working. I will not go in detail, but one thing I will tell you that these feather plants are now the need of the hour. So we are mostly importing the plants from different countries like Netherlands, Europe, European countries, USA, and some other countries. They are producing this plants. They have the main market now, the India. They are focusing on the India because we are not able to produce the other plants of that quality which they produce because we have more plant growth related available in the commercial formulation, and they have started very early. But we are trying hard to develop technology. We had already developed one technology, but still farmers have not taken up so much on that large scale. But we are trying that farmers should at least start this so that they will be altogether for this plant. This is the general way how we multiply the rootstock. There are big technologies. Because rootstock is a very important. I told you in case of template food, the sign variety is very important, but the rootstock is more important than the sign variety because it governs everything of the plant. So, but this rootstock is a limitation for us, so we are most relying on the import due to lack of these rootstock. One is rootstock and the second is other plant. If you don't have rootstock, then the technology of other plants will not survive. So our focus was to develop both technologies for other plants and rootstock. There are two methods available in the world to which these apple kernel rootstocks are multiplied. They cannot be multiplied by seed because I told you that seed is a cross-pollinated and heterozygous in nature. Secondly, it cannot be multiplied by any other method than other than the vegetative method. Other method is the tissue culture. A tissue culture we need a huge, huge infrastructure and huge investment. It is not possible for every grower to have this tissue culture lab. So these are the technologies we have developed in the greenhouse condition. These three technologies actually. The problem was that this earlier field, this mound layering, storing, and ground layering, this was a 2-year cycle. So in order to reduce the cycle and in order to increase the number of the daughter rootstocks, we developed two technologies and we have been able to success to get the success with some extent. These are the technologies, three technologies we have developed. First, we have developed the cutting technology because the cost of this rootstock is not less than 90 or 100 rupees, even 120 also. So if you are producing 100 rootstock, you will get even 10,000 rupees. So it is a very big business here. People are not getting rootstock, even if they are getting on low price, but that rootstock is not prototype, and you cannot say that whether the rootstock is genuine, the quality plant it is prototype. There is no guarantee. So it is better way to develop their own rootstock if they don't have enough capital to start there. And so we developed one low cost technology. Here we started cutting because these cuttings are of no use. After grafting, we are cutting almost 80% part we are cutting of the rootstock and then we are doing grafting. We started, we got almost 90 to 80%, 80 to 90% success, even 100% success in some rootstock. These are the rootstock which we harvested from cutting. This is when we develop these beds because for farmer cost will be farmer costly. These are the beds we developed and then we got rootstocks from this. There was variation in year to year and rootstock in certain sectors, but still we are getting 89, 70, 80, sometimes 60% success in the rootstock. These are all rootstocks that we have developed with creative technology. And currently also we are using technology to develop it. One more concept was here that this rootstock attains the height of 6 feet in the greenhouse and 3 to 4 feet in the in nursery. So we use this concept to utilize the vertical side, vertical growth of the rootstock. So we try to uh, initiate the rooting at different spaces. We use different media for this, almost 30 media, and different growth concentrations in order to different packaging material. We use different pots. We use. So we got success in developing the root stock. And earlier we were getting one root stock from one this plant, but now we and farmers are getting 4 root stocks from the same plant. That means we were getting 90 rupees or 100 rupees. From this, now we are getting 500 rupees without additional cost. And the cost of the production of this root stock is 6 rupees, including labor. So if we that is very major and no extra nutrients you have to do. Just you have to pass on these for the polybag and you have to put media, you have to use growth regulator, then you will get the extra plant and better rooting than the original plant. These are the root stocks you can see rooted. And you can tie 4 or 5 plants in one polythene up to now. This is the technology which has been recognized by the Indian Council of Agriculture Research also. This has been published by the annual report of the ICR with full technology. Otherwise, they are putting one paragraph, they are putting 50 lines. There are 206, almost 120, or including, if you include revenue stations, then there are more than 300 in the station. But getting this much space in your technology in annual report is a big achievement for all of us. So this is the technology which has been published in 2023 annual report of ICR. This is the success story which farmers have adopted these technologies, and ICR has also uh, promoted these technology and also published it on their official website several times in 2022-23 also. The success of this story, how this technology has changed the life of the people. Then we started in other rootstock also the same technology for airline technology, and we got success in queens also. By cutting also we got the success, and root system was amazing. And in all roots, clear rootstocks, and in other crops also we try to develop those technologies like we will great like that. We got success to some extent. And so on. These are the same technologies. Then this is the commercialization of the technology. We have commercialized this technology so far to almost 17, 18 farmers throughout the country, from JNK to Himachal to Karnataka and to Arunachal Pradesh also. And we have sold this technology to multiple users, and we have MOU with those users, and we got collected the fee. And so far we have collected more than 1 lakh fees of this technology from various growers of the country. This grower is from the Karnataka, and one of our farmer who has adopted this technology on large scale has been awarded Innovative Farmer Award, National Award, 2 national awards. One is Million of Farmer Award. That means his income has now crossed 10 lakh rupees per annum, and another Innovative Farmer Award for adopting, for promoting, and for this technology. We have also started a breeding program, appropriate stock with these OBP. We have also already submitted this project somewhere, but so far we are working here. So I am not elaborated it so. So we have first collected the millets, the data and millet settlements variant from different Himalayan regions of the country, and we have studied them, established them, and evaluated them through morphological and molecular ways. And then these are the various hydrotypes of Bacchata series we have collected here, and we evaluated their flowering was the main concern because we have to use them for breeding. So this is the molecular availability present in the Bacchata variant, and then we evaluated them. This is the sum of the breeding population we have developed at PAPS technology. We have processed, we have developed a lot of huge population we have. We are evaluating, and this is the routing in those populations. And we are studying on different traits associated with those population every year because this cat is huge population. And routing, because routing is most important. If you have developed rootstock and it is not multiplying, then your rootstock will remain in your institute only, will not go to farmers because how farmers will multiply it. So we are trying to multiply it. You can see the routing of the rootstock we have developed in a multiplication block. They are very strong, and root stem is also very. This is a weak, some weak, very weak rootstock. So we are characterizing it. We are studying the physiology also, like stomata, how much is the stomata available, so that we came to know about the dwarfness, how much, because the stomata runs to and size number is directly related with the physiology of the plant. So this is some stomata study. And we are also evaluating it for those populations for various diseases, like we have inoculated phytophthora. Uh, we can say Dimetophora, this white root rot, Dimetophora nicatus. Yes. Because we have problems mostly in nursery, and we have been able to select some population out of this, which are currently under evaluation. We have shown the tolerance or the resistance to some extent, and we are studying at the gene level, also molecular level, and by using markers. And some rootstocks have shown better resistance than the existing rootstocks of the world. So we are hopeful that out of that population we will get some good rootstocks. This is the inoculation. This is the devastating, how much devastating this disease is. And this is the rootstock of your developed rootstock, root system, how much strong it is, because the strength of the plant is directly related with the strength of the root. So we are focusing on the root also, and also we are studying the structure of the root, how it proliferates in the soil. That's why we are using this type of media, so that we will get the idea how is the growth of the root system. These are various food stuff which we have developed by working. Then I have one more crop which I am working. Dr. Javel is working on apple and I am working on pear. So we have started this breeding program in 2017, 16 also, but 17 formally. So we have some traits also, like first trait was long shelf life, and also this quality, storage life, and color and self-compatibility. We use a different parents. This is the first breeding program from India. You can it has been programmed and implemented. And now, if you will find now some literature in future, you will find the name of the India that this breeding program is going on. So these were the varieties we have introduced for different traits, and then we use our own varieties which have been acclimatized here long back, you can say, as a source of different traits. So we study the flowering, because flowering is very important for because the time of flowering and the duration of flowering is very important for breeding. So this is the data we generated, and we started the breeding in 2017. Then we developed the process, various process, random process, respiratory process, and then we got some success. First we got some failure also, but later we standardized the technology process. Because survival was less. Then we raised the plant. This is the plantation. We started with very less, but then we increased the number process. We evaluated some of them in the field. It's a very long process, it's not one day. You feed at least 6 times for evaluation. These are the hybrids we got. They are under evaluation some, and these two hybrids we developed for in case of Asian pear, because there are two types of pear, one is Asian and one is European. The Asian pear are different from, they are low chill also. They can be grown in other parts of the world, India, like Punjab, Haryana, and you can try in Assam also, or some the very minimum, the cooling are available. Because last year we planted them in Arunachal Pradesh and also in Haryana. So we are waiting for the result. These are two more varieties, one of them, but they are low, high chill varieties. They can be grown only in temperate region mostly, because they have been bred for this region also. They are also very good tasty varieties. And the most important thing is the shelf life. They have better shelf life than existing European pears present in the world, in any the world. This is, these are these hybrids. On left side is the garment, which is one of the best variety of the world. On second and right side is the CAPA hybrid, which we have developed here by cropping. This is we studied the this shelf life also. Shelf life, storage life is very important in case of pear because we cannot store the pear in storage also, cold store also. So we'll start this program and you got the success. You see this is after 3 months of storage. Otherwise, we cannot store that here in say 10 days in storage. But this here is after 3 months in storage. So this is very good. They are very promising results. And this is one of our hybrids also after 3 months in storage. This is common comparison to existing varieties of the world. This is our hybrid. And we have also done the this, uh, organoleptic evaluation, sensitive evaluation, because finally these products have to be eaten by the consumer. It is not attractive to consumer. If it is not tasty to consumer, it is shelf life is very good and it is attractive, but it is not tasty. Then for some time, some period of time, it can get promoted, but after that, people will not like it. Finally, it is the taste and taste does. Attraction is first, but finally it is taste. So we have done the organoleptic evaluation, and I will tell you and I will guarantee you. I will show you that slide. This is our dietary and we see of the cost during the sensory evaluation. And in this picture, you see there are one active DG, Dr. Pathak, and two former DGs, Dr. Sulotan Mahapatra, Dr. Uh, I forget the name, but three DGs are there, and two DDG, three DDG, uh, three ADGs who have evaluated this last year, and their evaluation was very costly, and we are hopeful that these varieties will come in the market and they will rule the market, hopefully. Uh, so thank you very much for my presentation. I told you I will do the presentation for
Thank you, sir.
the teacher. It was on our presentation. So if there are any questions, we can ask. You can ask
Thank you.
the mail or can I stop like this presentation?
Yeah, you can install this. So at times your voice was not clear. Please look into this. At times it wasn't good. The voice.
You should have told in beginning so that we don't have to